All right, so section 1.5. 1.4 was linear equations. 1.5 is quadratic, so we're moving into the quadratic style equations. We saw that in intermediate in the second unit that we did. So some of them involve factoring. Not all, but some do. So this would be an example of one that was involving factoring. We talked about the AC method. You can use that. We talked about trial and error. You can use that. Trial and error works pretty nicely on this one because the A value is 1. That's when we found out that the AC method was most valuable, is when the A value is not 1. So I'm going to use trial and error on this one. We have x and x to give me the x squared. Actually, I'm going to do this first. The sign here is negative, which means I need one negative and one positive. And then I need two numbers that multiply to 8 and add to 2. 4 and 2. And I need the 4 to be positive and the 2 to be negative so that I get a positive 2 in the middle. Okay. If you don't want to do it the way I just did with trial and error, you can use the AC method. That's totally fine. So you're going to factor it one way or another. And then you're setting each piece equal to 0. And solve. So we're going to add the 2 to both sides. So x is 2. And subtract the 4 from both sides. And x is negative 4. Okay, any questions on that? All right, so one option, and this one's the one that we've done the most with quadratics, is factoring. The other option, I think that we saw it, but we probably didn't sort of embrace it fully because it didn't have a lot of questions related to it in this idea. So number 2 talks about the square root process. What I would like for you to notice in problems A and B here is that you don't see an x term. You have an x squared right here, and you have, again, something squared right here, right? So you've got a quantity squared, and then you have constants. So this method works when you have a quantity squared and constants. So what we're going to do is we're going to isolate the squared term because I don't have a linear term to worry with. So you can't do that over here because there's that 2x in the middle that's causing problems for that to be possible. So I'm going to move my 8. So now I have x squared equals 8. This is the form that we saw it in before. What did we do when we had something squared equals a number? Radical. We did a radical. We took square root from both sides. You have to remember when you do the square root to do what? Plus or minus. Now, I also need to reduce my 8. So 8 factors into 2 and 4, and the 4 is another couple of 2's. So I have 3 2's here. Yeah, so it'll be plus or minus first, and then the 2, radical 2. Do make sure that the plus or minus comes before the 2 and not between the 2 and the radical part, because that's not correct. It's not addition and subtraction. It's really just positive or negative. We're going to do it. We're going to do it on part B. You'll see. I think it'll answer your question. If it doesn't, ask me again. Okay? So just a second. All right. So on this one, you have something squared, and it's equal to a value. And we are taking the square root of both sides. Now, when I take the square root of the value squared on the left, I get x minus 3. On the right, there's a couple of things that we need to be aware of. The first issue is that I have a negative underneath the radical. That's okay. We learned how to deal with that. We did. What did we do? We pulled out an I. Okay. And then my square root 20, well, I'm going to go ahead and factor that down. That is going to be a 4 and a 5. And the 4 is a 2 and a 2. So we have 2 times 2 times 5. You're exactly right, Maxwell. We have 2i and radical 5. And I left something out. Do y'all know what I left out? Yeah, I left out my plus or minus. Let me shift this over so I have some space. I still have to do plus or minus even when there's i's involved when I take square roots. It still happens. Okay? Okay, so I'm not done on this one, and I think this is what your question was going to be. Okay, I still have this saying x minus 3 on the left. So I still need to move the 3 over. So I will add my 3, but what you need to realize is that it doesn't combine with the other pieces. Right? Because this piece has an I and a radical in it, and the 3 doesn't. So the best that I can do on this one is to put the 3, basically, in front of the plus or minus. So x equals 3 plus or minus 2I radical 5. Is that all right? Okay. So we've got two methods. We've got factoring. We have the square root principle. It's very specific, right? Square root principle only happens when I have something squared, a quantity squared, and it's a constant as everything else. The next one is completing the square. You guys didn't like this too much when we did this with circles. It's still quite the same for doing it here. Let me show you how it works with completing the square, and I have a couple of examples. So what we're going to do is we're going to leave the m squared and the 12m on the left-hand side. And we're going to move the 33 to the right. So I'm going to subtract 33 over to the right. So now there's a space, and I have a negative 33.
So you subtracted 33?
Yes, I subtracted 33, and I didn't give myself quite enough space. Let me shift it a little bit. So it's like I did this. I just subtracted the negative, or subtracted the 33, subtracted the 33 to both sides. Okay, so the reason I left the space, this is what we did last time, right, is because the key to completing the square is to take b divided by 2 and square it. That's the key. What is the b value in this problem? Negative 12. That's b. So for my problem, I have negative 12 divided by 2, which is negative 6, and negative 6 squared would be positive 36. Yep, we need a positive. Yeah, we'll always get a positive when we do it when we're squaring. And if I add 36 to the left-hand side, I need to also add 36 to the right-hand side. It's a balance. I need to compensate. So on the right-hand side, that's 3. On the left-hand side, the reason that completing the square is so nice is because the factoring ends up being a perfect square. So the m comes here, the 36 square rooted is a 6, and it comes here, and the sign is a negative with a square on the outside.
It confuses me a little bit. So I'm trying to, whenever I think of factoring, I think of like kind of what we did before.
I like it.
You can always do it that way, Haley. It'll still work. M squared means I have m times m. The signs matching means, or the sign at the end being positive means the signs match. The negative in the middle means that they're both negative. And then in order to get two numbers that multiply to 36 and add to 12, they'd have to be 6 and 6.
Okay.
So you can still do it that way if it bothers you to do it the other way.
Okay.
The other way is a shortcut, but if you don't like the shortcut, just don't use it.
Okay.
Yeah. So either way, we end up with m minus 6 squared equals 3, and then it looks just like b over here, doesn't it? Yep. So now, after I've completed the square, I use the square root principle. So we'll square root both sides. I have m minus 6 on the left, and I have a positive or negative radical 3 on the right. And then what? Add my 6. Absolutely. Good job. 6 plus or minus radical 3. Okay. All right. I've got one more of this variety to show you. Completing the square variety anyway. I don't know why I had that there, but here we go. Oh, because there's a typo. This shouldn't say this. All right, B should say, oh wait, maybe it was.
3x squared plus x equals 2.
Here we go, 3x squared plus x equals 2. All right, so completing the square had this caveat that I didn't mention before because it hadn't come up yet. This key to completing the square is to take b over 2 divided by 2 and square it, right? All of that hinged on the fact that there was a 1 coefficient for a. This problem doesn't have that. Okay, so I can only do what I'm about to do if there's a 1 coefficient for a. So do you know what I have to do before I can even complete the square here? I need to divide everything by 3. And yes, I do realize that that makes things not not into whole numbers. There are fractions now. I get it. So now I have x squared. I'm going to write it as the fraction 1/3 x. And this equals 2/3.
And that's because you can't have like a number in front of the
Right.
first.
I need a 1 in front of the squared term. Madison? Yeah. So in order to complete the square, I first need a 1 in front of the x squared. So that means that this now is my b value, 1/3. So I'm supposed to be doing b over 2 squared, right? So this is 1/3 divided by 2 squared. You don't. I promise you don't. Your calculator is going to make it kind of ugly. What is 1/3 divided by 2? What's half of a third? It's 1/6. What is 1/6 if you square it? 1 over 36. I know they're fractions, but it's actually not an awfully ugly one. Okay? So we've got 1/36 on both sides. The right-hand side is kind of challenging because I need to get common denominators. What would I have to multiply 3 by to get 36? 12 is correct. So this is going to be 20, this one right here is 24 over 36 plus 1, which gives me 25 over 36. You have no idea how wonderful that is, which you're about to know in just a minute. Okay, so on the factoring here, I'm going to still do my shortcut even though Haley doesn't like it. This one's square rooted, that's an x. This one's square rooted. What's the 1/36 square rooted? 1/6. It's just the number I got before I squared right here, right? And it's positive because there is a positive sign on the middle term. I need a square on the outside. All right. I can take a square root. That's x plus 1/6 on the left. I know I have a positive or negative. What's the square root of 25 over 36?
5 over 6.
Okay. You don't need a calculator for that because this 25 on top is perfect and the 36 is perfect, and that's why this is such a beautiful number to get at the end. It's actually really nice. What's that? Right, because we actually, like, this is actually like 5 times 5 and 6 times 6. So when we do the square root, it eliminates on both parts. Yeah. I do still need the plus or minus, though. Okay? I still have to have that. And then what's my last step? Subtract 1 over 6. I'm off my screen. Let me make this just a little bit smaller so that we can actually all see it. Now, it's actually a little bit more difficult on this problem to do that because they do combine, right? The other 3 problems that I've done that have involved radicals so far, there's no way to combine the radical with the whole number part that I moved or the fractional part that I moved. I don't have that possibility. But here I do. So I have 5 over 6 minus 1/6, and I have negative 5 over 6 minus 1/6.
4 over 6.
So the first one is 4 over 6, which is 2 over 3. The second one, what's negative 5/6 minus 1/6? Yeah, negative 6/6, which is negative 1. So my 2 values that I'm getting are 2/3 and negative 1. We don't, because we actually did the plus or minus when we separated them. Here was the plus and here is the minus. They're a lot harder when they actually simplify. The radicals being involved actually make things easier for us. Okay. I didn't get to sing to you in intermediate algebra, so I get to sing to you today. Are you ready? So, yeah, there it was. Quadratic formula. Right? You've seen it before because we've talked about it briefly, but except I didn't get to talk to you about it in real time. I just posted one because I was gone that day. So the quadratic formula says the following. X equals negative b plus or minus radical b squared minus 4ac all over 2a.
Is that Beyonce?
No, no, it's great. Do you know the tune? It's Pop Goes the Weasel. It is Pop Goes the Weasel. So, of course, then one of my children in my house, my 11th grader, had to go look up the actual words to Pop Goes the Weasel when she learned the quadratic formula, and her teacher sang it to her last year in class because that was interesting. Okay, the quadratic formula is actually very nice, and y'all know how to do it because we've done it before. And the reason it's nice is because it has specific places to evaluate and plug in certain values. The catch that you have to remember is that you have to have it in this form. It has to have everything on the left and 0 on the right. So don't get ahead of yourself looking at our first problem and just start plugging numbers in. First, you need to shift them. In particular, we need to subtract the 6x to the left, and we need to add the 13 to the left. So we really need to write this down first as x squared minus 6x plus 13 equals 0. Let's run through this question real quick, and then we'll pause for today. And the last thing that we won't cover is discriminant. So any homework problems in my math lab that say something about discriminant, just postpone that and do the rest of them before them. So my A value is 1, my B value is negative 6, and my C value is 13. So we have x equals negative b, which would be positive 6, plus or minus the square root of b, which is negative 6 squared, minus 4, a is 1, c is 13, over 2 times a, which was 1. And we will simplify. Negative 6 squared is 36. Negative 4 times 1 times 13 is negative what? 52. 2 times 1 is 2. What's 36 minus 52? Negative 16. Oh, that's a very friendly number, actually. The negative means that there's going to be what come out? An I. But what's the square root of 16? 4. So this is plus or minus 4i over 2. And again, I'm off screen because my screen is smaller. Okay, so I have 6 plus or minus 4i over 2. And the 2 will factor out, right? Each of these divides evenly with the 2. So I end up getting 3 plus or minus, yep, the 2i. Okay, all right, so 1.5 is assigned, but it's not due on Monday because there's a small piece at the end we haven't covered. We should finish that piece in 1.6, so be prepared that on Tuesday you're probably going to have both of those assignments due. I would do as much as you can of 1.5 over the weekend. Have a great weekend, guys. I'll see you on Monday.